In Module 6, we're going to talk more about our trig functions and their graphs, and we're going to start with the graphs of our sine and cosine functions. So we're going to talk about what you need in order to graph them and then practice graphing different types of sine and cosine functions. So we're going to start with the sine function. So its parent equation is just y equals sine of x. Its domain, so there's any value I can plug into the sine function for x. So its domain is from negative infinity to infinity. The range, however, is different. If you remember from the unit circle was, if we looked at the y coordinate, y coordinates we got for all of the different points, which represented our value of sine, we couldn't get any value. So the range for the sine function is actually only defined from -1 to 1. You're never going to get any y value greater than 1 or anything less than -1. And there are special cases where you can. We'll talk about those later. But the general function y equals sine of x only has a range from -1 to 1. So let's go ahead and use our unit circle to create a table of values for our sine function. So, and I'm going to use radians for our angle. So if you're going to use a calculator or Desmos, make sure your calculator is in radian mode, and Desmos is automatically in radian mode, so you don't have to worry about changing it. So we know for the unit circle, we start at 0 and we end at 2 pi. So now we just want to fill in 3 other values to graph our function. And I'm just going to use our different axes. So our 90, 180, 270 values. So that would be pi over 2, pi, and 3 pi over 2. And to find our y value or sine, you can use the unit circle since these are all points from unit circle. So at 0, sine is 0. At pi over 2, sine is 1. At pi, sine is 0. 3 pi over 2, sine is -1. And at 2 pi, which is the same thing as 0, sine is 0 again. So we're going to use these angles and values to graph our function. So we already know the y value is going to have to be between -1 and 1. So now we just create our x values from our angles. So 0 is already marked. We have pi over 2, pi, 3 pi over 2, and then 2 pi. So now we just have to graph our points. So 0, 0, pi over 2, we're at 1, pi, we're at 0 again, 3 pi over 2, we're at -1, and at 2 pi, we're back at 0. Now, when we connect these points, it's going to be a curve. They're not straight lines. The trig functions have curves. So when I connect the points, this is the graph of the sine function between 0 and 2 pi. Important when graphing sine and cosine function are some vocabulary terms that you may not be used to. So one of those is period. It's the x distance it takes to complete one cycle. So if we look back at our graph of sine, one cycle is, the period is going to be 2 pi. It's when we go up to 1, down to -1, and end back at where we started. And for sine, we start at 0. The cycle is one period of a function. The frequency is the number of cycles completed over 2 pi. So our cycle is the graph we got, and then the frequency is the number of times we can fit that graph into 2 pi. So in our graph of sine x, the frequency is 1 cycle over 2 pi. And another important vocab word is amplitude. It's the distance between the midline and the maximum or minimum value, and it's always positive. So the midline in our sine function is actually the x-axis. So the distance between the midline and the maximum or minimum, our maximum is 1, our minimum is -1. So that distance is just 1. So if we look here, for the graph sine of x, the period is 2 pi, and the amplitude is 1. So next we're going to move on to the cosine function. So its parent graph, or its equation, is just y equals cosine of x. Similar to the sine function, its domain and range are the same, from negative infinity to infinity for the domain, and the range is also from -1 to 1. And again, the range comes directly from the unit circle. If you look at all of the different points, the cosine values or the x values are never greater than 1 or less than -1. So again, similar, we're going to use the unit circle to create our table of values. We're going to have the same angles as we did for sine. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now the cosine values are not the same. So at 0, cosine is 1. At pi over 2, it's 0. At pi, it's -1. At 3 pi over 2, it's 0. And at 2 pi, it is 1. So our axes are going to look very similar to our sine function. We're going to have 1 and -1 for our y values, and then for our x values, we're going to have pi over 2, pi, 3 pi over 2, and 2 pi. So we're now going to graph our points. At 0, we're at 1. At pi over 2, we're at 0. At pi, we're at -1. At 3 pi over 2, we're at 0. And at 2 pi, we're back at 1. So we connect our points again, we get a curve, and we get the graph of cosine from 0 to 2 pi. The vocab we just went over for the sine function gets applied to the cosine function as well. We can fit one cycle of our graph over 2 pi. So our period is still going to be 2 pi, and our amplitude is still going to be 1. So if we go ahead and look at the period of each of our sine and cosine graphs, this first one is sine, and our second one is cosine. We have all of those things we just talked about labeled. We have an intercept where we start at 0, 0, the maximum of 1, our minimum at -1, and we have one full period graph. So we have all of these nice pieces of information labeled. Some of these are familiar, like intercepts, and maxes and mins, and some of them are new, like our periods. So let's go ahead and talk about general equations and transformations of our sine and cosine graphs. So just like with any other graph we've talked about, there are transformations that can be applied to sine and cosine. So if we look, the y equals a sine of b times x plus or minus c plus d, and y equals a cosine b times x plus or minus c plus d are the general equations for sine and cosine. And a, b, c, and d all represent different types of transformations that can be applied to those graphs. So we're going to start identifying how those letters affect our sine and cosine graphs. And we're not going to talk about all of them in this section. Some of them are going to be talked about in section 2. So we're only going to talk about a few of them right now. So our amplitude is going to be represented by the absolute value of A. The frequency, so the number of cycles that can fit in one period, is going to be b over 2 pi. And our period, so frequency and period are very closely related. Our period is actually the reciprocal of that. It's going to be 2 pi over b. So the phase shift. So phase shift can kind of be thought of like a vertical shift. A phase shift can be thought of kind of like a horizontal shift with a regular graph. So it's going to actually move our graph left or right. And the way we figure out how much that graph has been moved left or right is to do -c over b. And a vertical shift is going to be up or down in this case. And that's going to be represented just by d. So if the c value is positive, our phase shift is actually negative, which would be left. And if the phase shift is negative, it's going to be right. So a horizontal stretch or compress actually changes the period, So if you stretch the function, the period gets larger, and if you compress it, the period gets smaller. So we're going to go ahead and take a look at that right below. So if our b is greater than 0, we have the graph f of x equals sine of bx. So that makes b cycles in our interval 0 to 2 pi, which is where we get the frequency. So the period of that function is 2 pi over b. If we divide our period by the number of cycles, we're going to get the period of the function. And it's the same for our cosine graph. If b is greater than 0, we have cosine of bx. There are b cycles in the interval 0 to 2 pi. So to get that period, we do 2 pi divided by b. So let's go ahead and find each of those for our sine or cosine equation. So if we look at our first example, we have y equals 4 times sine of x minus pi over 4 plus 2. So we start with the amplitude. The amplitude is the absolute value of a. And in this case, a is 4. So we want to do the absolute value of 4, which is going to be 4. Our frequency, which is b over 2 pi. Well, b is going to be the number in front of x, which is just 1. So we're going to have 1 over 2 pi, which means in our period of 2 pi, we're only going to fit one sine graph. So that ties directly into our period. It's going to be 2 pi over 1, which is just 2 pi. Our phase shift is going to be negative c over b. So I have negative. C is going to be negative pi over 4. And b is just 1. So negative pi over 4 all over 1 is just going to be pi over 4. So this means that our graph has been moved to the right pi over 4. And our vertical shift is the number at the end. It's a plus 2. So our vertical shift is just 2. Moving on to our second example, we have y equals negative 2 times the cosine of 3x minus 1. So our amplitude is going to be the absolute value of a, and in this case, we're doing the absolute value of negative 2, which is going to be 2. And the reason why we do the absolute value for amplitude is because it's distance, and distance is never going to be negative. That negative is going to come into play later on, and I'm going to explain that at the end of notes in a different example, how the negative affects our equations. Our frequency, b over 2 pi. B in this case is 3, so it's going to be 3 over 2 pi. Our period, which is 2 pi over b, is going to be 2 pi over 3. Our phase shift, well, we don't have a c in this case since it's just 3x, so that would be a negative 0 divided by 3. So because we don't have a c, our phase shift is 0. We haven't moved left or right from the original graph. Our vertical shift is just the number at the end, which is going to be negative 1. Last example, y equals sine of 2x plus pi. So in this case, our number in front of sine is just 1. So we're doing the absolute value of 1, which is just going to be 1. Our frequency is going to be b, which in this case is 2 over 2 pi, which we can simplify to 1 over pi. So what this means is over the course of 2 pi, we can actually fit 2 of our sine graphs, or 1 in the course of just pi. So our period is going to be 2 pi over b, which is 2, which becomes just pi. Our phase shift is going to be negative, and in this case, c is pi over b, which is 2. And our vertical shift, we don't have a number that's being added or subtracted at the end, so it's going to be 0. We don't have a vertical shift. So now that we can identify each of the different transformations of a sine or cosine equation, we can apply this to graphing sine and cosine functions that have been transformed. So there's a nice strategy that'll help you graph sine and cosine function, and that's to always find the period and phase shift first, and then figure out where one cycle will start and end. And then we use 5 key points for the graph using this information. So we're going to start with graphs that have different amplitudes only. So if we start with y equals 2 sine of x, we want to find its period and phase shift. So the period is going to be 2 pi over b. Well, in this case, b is 1. So our period is going to be 2 pi, and our phase shift, which I'm going to abbreviate PS, we don't have a c, so it's also going to be 0. So this is telling me my graph isn't compressed by any amount or moved left or right from the original graph. So that means when I pick my 5 key points, I can use the 5 points that we used when we graphed our parent function y equals sine of x. So our angle x in our graph y equals 2 sine of x, my angles are going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Since we already know what these y values are for just sine of x, the 2 tells me I'm going to multiply each of those original values by 2. So when we had our parent function y equals sine of x, when I plugged in 0, we got 0. So now we just have to multiply that by 2, which is going to give us 0. Pi over 2 gave us 1, which when we multiply by 2 is going to give us 2. Pi was 0, times 2 is 0. 3 pi over 2 gave us negative 1, which when multiplied by 2 is negative 2, and 2 pi was 0, so we get 0 again. So this is only going to affect our y-axis. So instead of having just 1, we actually have to go all the way to 2 and negative 2. Our x-axis is the same. We have pi over 2, pi, 3 pi over 2, and 2 pi. So now we just graph our points. We have 0, 0. Pi over 2 is at 2. Pi is 0 again. 3 pi over 2 is negative 2. And 2 pi, we're back at 0. And we just connect our points to get our graph. Next, we have y equals 3 cosine of x. So first, we identify the period and phase shift. Well, b is just 1, so our period is going to be 2 pi. We don't have a c value, so the phase shift is 0. So again, just with the parent function of cosine of x, I don't have to change what angles I pick for x. So we're going to have 0, pi over 2, pi, 3 pi over 2, and 2 pi. So because we haven't changed the x values, we can use that table for our parent function to help us figure out the y values. Well, when we plug in 0 for cosine, we got out 1. And because I have that 3 out in front, I have to multiply it by 3. So when I plug in 0, we're going to get out 3. Pi over 2 originally gives us 0, which when multiplied by 3 is still 0. Pi gives us a negative 1, which when multiplied by 3 is negative 3. 3 pi over 2 gives us 0, which when multiplied by 3 is still 0. And 2 pi originally gave us a 1, which when multiplied by 3 is 3. So we have to create our y values, which have to go up to 3, and then to negative 3. And then our x values are the same, pi over 2, pi, 3 pi over 2, and 2 pi. So now we just graph our points. We start at 3 for 0, then pi over 2 is 0, pi is negative 3, 3 pi over 2 is 0, and then 2 pi, we're at 3 again. Connect our points to get one cycle of our cosine function, or one period. Now let's go ahead and figure out what graphs look like when we have negatives. So the negative only affects the y values when we graph it. So if we start with our period in our phase shift, b is still 1, so our period is 2 pi, and our phase shift is still 0 since we don't have a c value. Which means our table isn't going to look any different for the x values than it did from all of our other examples. So we're going to have 0, pi over 2, pi, 3 pi over 2, and 2 pi. Here's where the negative comes into play. It actually reflects our graph over the x-axis, just like it did when we were transforming our other functions. The negative reflects it. So it's just going to have an effect on our y values. So we use the same y values as our parent function, except we multiply them all by a -2. So we're going to end up with 0, -2, 0, 2, 0. So when we graph our function, we still do 1 and 2 on our, and -1 and -2, and our x values are still pi over 2, pi, 3 pi over 2, and 2 pi. And we're going to start at the same place, 0, 0. But instead of at pi over 2 and going up to a positive, we're going to go down to a negative. It changes the direction we start. Pi is 0 again, 3 pi over 2 is a positive 2, and 2 pi is 0 again. So it's a reflection of our previous example if you compare the two graphs. So with y equals -3 cosine of x, it's going to be the exact same way. Our period is still 2 pi, and our phase shift is still 0. So when we create our table of values, we're going to use the same 5 values we've been using for x, 0, pi over 2, pi, 3 pi over 2, and 2 pi. And this time, all of the values that we used for our parent function are going to be multiplied by -3. So we're going to end up with -3, 0, 3, 0, -3. Create our axes. Y values and x values, when we first label them, are going to be the same. So we have pi over 2, pi, 3 pi over 2, and 2 pi. So for cosine, unlike starting at the +3, we're now going to start at -3. Then we're going to go to 0. We're going to continue up to +3, come back down to 0, and we're going to end at -3. Now we're going to look at some examples where we have a period change. So that means that our graph is going to be condensed into a shorter period, or it's going to be stretched over a longer period. So we get y equals sine of 2x. So when we're identifying the period, we have to do 2 pi divided by b. And in this case, b is 2, since that's the number in front of x, which means our period is pi. That means I'm going to fit an entire cycle of our sine graph just over pi. Our phase shift is still 0. We don't have any c value. So this time when we create our table, it's not going to be the same as it has been. So our x value, we want to start at 0, like always, but instead of ending at 2 pi, which is our normal period, we want to end at pi, since our period is now only pi. So we want to be able to fit our sine graph from 0 to pi. And we just have to figure out how much we're going to go up by, because we can't pick our normal 3 points. So to figure that out, I want to be able to graph the same points. That way it'll be easier. So I have, if you think of it this way, to get to pi, I have 4 points that I want to use. So if I take my period and divide it by my number of points, I'll get what I want my scale to be. So in this case, pi divided by 4 is pi over 4. So we're going to use our pi over 4 label. So 0, pi over 4, pi, 3 pi over 4. And then our graph, y equals sine of 2x. So if we were to evaluate, sine of 0 is not going to be different. It's still going to be 0. So because we use pi over 4, when I do 2 times pi over 4, we get pi over 2. So that's going to give us 1. Then sine of 2 pi, which is 0. Sine of 2 times 3 pi over 4 becomes sine of 3 pi over 2, which we know is -1. And then we get sine of 2 pi, which is 0. And I did make a mistake here. It should have gone 0, pi over 4, then pi over 2, not pi. That should have represented our 90-degree angle. So instead of evaluating sine of 2 pi, we're actually evaluating sine of pi, which is 0. That's my mistake. Make sure you fix that on your notes. So when we graph our function, our amplitude hasn't changed, so we have 1 and -1. Our x values, though, those are going to be different. So we're going to have pi over 4, pi over 2, pi, 3 pi over 4, and then finally pi. So we start at 0, 0. Pi over 4, we get 1. Pi over 2, we get 0. 3 pi over 4, we get -1. And at pi, we end up at 0. So we've fit our sine graph, but instead of over 2 pi, it's fit over pi. And if we were to use Desmos to graph this function and set up the same scale for our x-axis, if you put it over 2 pi, you would see you could fit 2 sine graphs over the 2 pi. So now we're going to take a look at y equals cosine of 1/2 x. So when we identify the period, we have to do 2 pi divided by b. Well, that's going to be 2 pi divided by 1/2, which if we rewrite as multiplication is 2 pi times 2, which gives us a period of 4 pi, which means instead of our graph being condensed like it was in the previous example, it's going to be stretched out. We're going to be able to, instead of fitting multiple cosine graphs in 2 pi, we'd actually have to stretch it out further before we could even get one cosine graph. Our phase shift, because we still don't have a value of c, is still 0. So when we create our table of values, when we pick our angles, we know we want to start at 0 and end at 4 pi. In order to fit 4 points and end at 4 pi, if I take 4 pi, divide it by 4, we end up with pi. So I want my scale to go up by pi. So we have 0, pi, 2 pi, and 3 pi. That way I have it evenly spaced out. So we're going to have our y values representing cosine of 1/2 x. So cosine of 1/2 times 0 is the same. It's just going to be 1. Cosine of pi over 2, since when I take pi and multiply it by 1/2, I get pi over 2, is 0. Cosine of pi is -1. Cosine of 3 pi over 2 is 0. And then cosine of 2 pi gives us 1 again. And then I'm getting all of these values because I'm taking this x value I have and multiplying it by the 1/2. So 2 pi times 1/2 is just pi, which is why I know it's the same thing as cosine of pi. 3 pi times 1/2 is just 3 pi over 2, and then 4 pi times 1/2 is 2 pi. So our y scale is going to be 1 and -1. And then our x-axis, we're going to have pi, 2 pi, 3 pi, and 4 pi. So we have 0, 1. Pi, we're at 0. 2 pi, we're at -1. 3 pi, we're at 0. And at 4 pi, we are back at 1. So again, connect our points. We get one graph of the cosine function. And again, you can always use Desmos to double check your graph and just make sure that your step on Desmos matches your step that you have, your scale that you've picked for your graph on paper. So now let's go ahead and graph where our phase shifts have changed, which is going to change the way we look at our graphs. So if we look at y equals sine of x plus pi over 2, my period is still going to be 2 pi. It's going to be 2 pi because the number in front of x is 1. My phase shift is, however, going to be different. So now I have that c value. So we do negative c, so in this case that's going to be negative pi over 2. And because b is 1, I know it's just going to be negative pi over 2 for my phase shift. So what this tells me is if I take my parent function of sine, I'm going to move it to the by pi over 2. So my starting point has now been moved to the left by pi over 2. So when we pick our table of values, right, because my period is still 2 pi, I know I'm going to start at 0 and end at 2 pi. So in this case, a phase shift, as long as the period is still 2 pi, doesn't affect the x values for pick. So we're going to go back and pick our original x values. 0, pi over 2, pi, and 3 pi over 2. How the phase shift affects it is our y values. So y equals sine of x plus pi over 2. So because my graph has been moved to the left pi over 2, that means that 0 is actually going to start 1 to the left on my graph. So at 0, I'm actually starting at basically what would originally be pi over 2, which means if you think of what sine of pi over 2 is, that's actually going to be 1. So we're going to start at 1. Sine of pi over 2 is going to be, that from our original graph, is now going to be sine of pi, which is 0. Sine of pi is negative 1 now. Sine of 3 pi over 2 is 0. And sine of 2 pi is now 1. So we go to create our graph. So we have 1 and negative 1. We have the pi over 2, pi, 3 pi over 2, and 2 pi. We have 0, 1, pi over 2, 0, pi, negative 1, 3 pi over 2, 0, and at 2 pi we have 1. So it looks like if we look at from 0 to 2 pi, it looks like our cosine function. So if I were to actually graph at negative pi over 2 though, graph that point, negative pi over 2 would be my original sine of 0, which is 0. So if I were to actually look at my graph, I actually only want to look at it from negative pi over 2 to 3 pi over 2, and that's going to give me what my sine graph normally looks like, the normal period for sine. It's just been shifted to the left by pi over 2. So now let's look at an example of cosine. We have y equals cosine x minus pi. So when we first look at the period, b is 1, so we're going to get 2 pi. And our phase shift is going to be negative c over b. Well, b is 1, so it's basically just negative c, which is going to be negative pi, which is going to give us pi. So because pi is positive, I know I've moved to the right pi. So if we start off with our x values, because our period is still 2 pi, we're going to have the original x values from our parent function. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. Our y values so now when we're filling out our table for the y values, we've shifted to the right by pi. So we're basically going to be starting with the x value starting at pi and moving by pi over 2. So cosine of 0, instead of being 0, you're going to treat it like we're starting at pi, which is going to start us at negative 1. Pi over 2 is basically cosine of 3 pi over 2, which is 0. Cosine of pi is pretty much cosine of 0, which is 1. Cosine of 3 pi over 2 is treated like pi over 2, which is 0. And then cosine of 2 pi is going to be pi, which is negative 1. So now if we go ahead and graph, we have 1 and negative 1 for our y values. Then we have pi over 2, pi, 3 pi over 2, and 2 pi. Graph what we're given. We have 0, -1. Pi over 2 is at 0. Pi is at 1. 3 pi over 2 is 0. 2 pi is at -1. So it doesn't quite look like our regular cosine. Because we know we've shifted to the right by pi, my original cosine graph would actually start at pi. So if I wanted to get an actual look of where my pi function is, if I go to 2 pi, after 2 pi comes 5 pi over 2, and then I'd continue on to 3 pi. If I continue my graph, I now can see my original cosine function fit between pi and 3 pi. That's my period of 2 pi, and I can see where I've shifted. I start at now pi, and I continue for a period of 2 pi to end at 3 pi. So one more type of example of graphs, and this is going to be with vertical shifts only. So we've only moved up or down. So if we go back to our period and phase shift, because I'm moving only up or down, my period is going to be 2 pi, and my phase shift is back to 0. So my x values, or my angles, are going to be the same: 0, pi over 2, pi, 3 pi over 2, and 2 pi. Vertical shifts are going to affect the y value. So y equals sine of x plus 1. So similar to when we only had amplitude, we're going to take our parent function values, but instead of multiplying, we're just going to add or subtract whatever value is at the end. So in the parent graph, sine of 0 is 0, but now we're going to add 1 to that. So we're going to end up with 1. Sine of pi over 2 is 1, but now we have to add 1, so we're going to get 2. Sine of pi was 0, but now we're going to add 1 to that, so we get 1. Sine of 3 pi over 2 was -1, so we add 1 to that and we get 0. And sine of 2 pi is 0, we add 1 to that and we get 1. So now when I go to create my y values, I actually have different ones. I only have 1 and 2. Don't have any negative values. Our x values are still pi over 2, pi, 3 pi over 2, and 2 pi. So at 0, we're at 1. At pi over 2, we're at 2. Pi, we're back to 1. 3 pi over 2, we're at 0. And at 2 pi, we're at 1. So we've just taken our sine graph and we moved everything up by 1. If I were to move this entire graph down by 1 again, I'd end up with my original parent function, sine of x. So it works similarly with cosine. I have y equals cosine of x plus 2. So we haven't changed b, so our period's going to be 2 pi. We don't have a c, so our phase shift is 0. So when we create our table, our angles are going to be 0, pi over 2, 2 pi, 3 pi over 2, and 2 pi. But our y values are going to be affected by the shift up 2. We have that plus 2. So cosine of 0 is 1. We're going to add 2 to that, so we're going to get 3. Cosine of pi over 2 is 0. We're going to add 2 to that and get 2. Cosine of, this should say pi, is -1. We add 2 to that and we get 1. Cosine of 3 pi over 2 is 0. We add 2, we get 2. And then cosine of 2 pi is 1. We add 2 and we get 3. So we only need positive x values, and we need 1, 2, and 3. Our x values are going to be pi over 2, pi, 3 pi over 2, and 2 pi. So we're going to start at 0, 3. Pi over 2 is 2. Pi is 1. 3 pi over 2 is 2. And 2 pi is 3. So if you're looking at So now we have our cosine function, which we can move down to get our original parent function. So if we're looking at the amplitude of this cosine function, the amplitude is 1, which you would normally think that would mean, okay, I have 1 and -1. But remember back to the definition of a amplitude, it's the distance from the midline. And the midline is that basic where I cut where my x-axis is. And anytime you've moved up or down, you have to think that you've kind of moved that midline by however much you've moved up or down. So in our first example here, the sine of x plus 1, you can think that you've moved that midline from the x-axis, so it was normally here, you've moved it up 1. So now that midline is going through 1. So our amplitude is still 1, it's just now in a different place. It's going to be the same thing with this cosine function. Originally my midline is the x-axis, but now that I've moved it up 2, it's now going through 2. So my amplitude is still 1 because my y values are still 1 away from that value. So your amplitude can't always determine where you're going to start on your y-axis. You have to take into account if there's a vertical shift of any sort that's going to change where your midline is for that amplitude. So not only can we graph equations using this information, but we can find the equations of graphs we're given. So if we're given the picture of a graph or given information about a graph, we can determine the equation. So let's look at our first example. So we have a picture of a function. We have to determine if it's sine or cosine. And unless specifically told that there's a phase shift of some sort, I would assume that there isn't one, especially if you're looking at a graph. Because the cosine function is a phase shift of the sine function, you could pick either one of them for this graph, but I'm going to go ahead and make it easier, and I'm going to pick, because I know the sine function starts at 0, I'm going to say we're looking at a sine function. So I know I have the parent function y equals sine of x. If you choose cosine of x, you would have a phase shift of some sort, and because we haven't talked about how phase shifts work, we're going to assume that we haven't moved left or right at all for these equations. So now I want to figure out any amplitude or period or vertical shifts. So if I look, the maximum is 3 and my minimum is 3. So this is going to tell me that I have an amplitude of 3. My midline is going to be the x-axis. And my period, so we know the period of a normal sine graph is 2 pi. So I should only go up to 3, down to 3, and then back to 0 over the course of 2 pi, which we haven't done in this graph. If you look, we go up to 3, down to -3, and end at 0 at pi. So my period is going to be pi in this case. The period is how many cycles of your graph you fit over 2 pi. And in this case, that would be 2, so 2 pi over 2. So now we have to figure out how to write our equation. So of amplitude and period tell me that I have a value for A and I have a value for B. A is just going to be 3. B is, now I have to figure out what B is. So I just talked about the fact that I can fit 2 of my sine graphs over 2 pi, which is the original period for sine, which is going to tell me that B is actually 2. And I'm going to show you that algebraically. So we think my period pi has to equal 2 pi over B. Since 2 pi over B is how we find a period, I know that if I plug B in, I'm going to end up with pi. So if I solve this like an equation I solve for B, we get B times pi has to equal 2 pi, which tells me that B has to equal 2. So now I have all of the information, I can write my sine equation. So we have y equals, A goes in front, so 3 sine, and then I have a B times x, so 2x. And y equals 3 sine of 2x is the equation for this graph. We can also write equations given information. So I tell you we have a sine graph that has an amplitude of 5. It's reflected over the x-axis. It has a period of 2 pi over 3, and we've moved down 2. So there's a lot of information that we're given. We're going to break it down by what we're given. It's a sine graph. So I know I'm going to start with y equals sine of x. We have an amplitude of 5. The reflection over the x-axis I'm going to come back to. Our period is 2 pi over 3. And we're down 2. So down, up or down is vertical shift. So I'm going to abbreviate that VS. Down 2 would be a negative direction, so it's negative 2. So now I have to figure out amplitude, period, and vertical shift are what letters? Well, we already know amplitude is A, period is B, and a vertical shift is D. So our amplitude is the absolute value of A. So I know A is 5, but because I have that reflection tells me that A is actually negative 5. B, so I know to get my period, I have to do 2 pi divided by 3. So in this case, because my denominator is 3, that tells me B is 3. And my D is just the vertical shift, so it's negative 2. So when we go to write our equation, it's going to be y equals negative 5 sine of 3x in parentheses and then minus 2. Please make sure, I know there's a lot of information in this section. You're asking for help when needed, especially if there's something you aren't quite understanding. Please ask for help over this assignment.